Hello everyone, I'm Julia, and in this video I'm going to be taking the integral of 10 over x minus 1 times x squared plus 9 dx. So the first thing we're going to do is change the denominator to, so the denominator is 1 over x minus this. We're not going to worry about the 10, the numerator yet, and we're going to change this to a over x minus 1 plus b x plus c over x squared plus 9. And then we're going to solve for the a, b, and c. And the reason we were changing things like this is because we can't take the integral of this in another way. So we're going to multiply this whole thing by x minus 1 and x squared plus 9. If we do that, we'll get, well, for a over x minus 1, the x minus 1, these two will cancel out. So we'll just have a times x squared plus 9. And for this one, the x squared plus 9, these two will cancel out, and we'll just have b x plus c times x minus 1. We're going to expand what we got here, and we'll get a times x squared plus 9a plus bx squared minus bx plus plus cx minus c. We're going to factor it again, but in a different way. We're going to group the x squares together, which will be x squared times a plus b. So just these two have x squared. And another group will be the x times these two, c minus b, and just the constants, which are 9a minus c. To find the values of a, b, and c, we're going to use the 10 in the numerator here. We have 10, okay, we can imagine the numerator as 0 times x squared plus 0 times x plus 10. These two are basically the same. So here we have x squared times a plus b instead of 0 times x squared, so that tells us that a plus b is equal to 0. And we have x times c minus b, and here it's 0 times x, so c minus b will be equal to 0. This doesn't have like x. It is just, you could think of it as x to the power of 0, but there's no point. And the 10 will be equal to 9a minus c. Using what we got, we can solve for a, b, and c. I'm going to add these two together to get a plus c is equal to 0, because the b and the negative b cancels out. And I'm going to bring this down to here. 9a minus c is equal to 10. And I'm going to add these two together again, these two equations. The c and the negative c will cancel out, and we'll have 10 times a is equal to 10. Solve for a, and you have a is equal to 1. We had a plus b is equal to 0, so if we put in a is equal to 1 here, we'll have b is equal to negative 1, and put negative 1 into this equation, and you'll have c is equal to negative 1 as well. We're going to put in the values of a, b, and c into here, this one, this part, but without these. Well, that will get us to, of course, we still need the integral, and a, which is 1 over x minus 1, plus b, which is negative 1, so negative x, c is equal to negative 1, and divide that by x squared plus 9. Well, we still can't just take the integral of this part, right? Well, we can take the integral of this part, which is ln absolute value of x minus 1, but we'll have to change this part a little bit. This is equal to 1 over x minus 1, and we'll separate this into two fractions. 1 is minus x over x squared plus 9. The other one will be minus 1 over x squared plus 9. We can now take the integral of this, and the integral of 1 over x minus 1 is, the integral of 1 over x minus 1 is ln absolute value of x minus 1. And for the integral of this part, we'll set u is equal to x squared plus 9, and using the u, we can solve for the du, which is 2x dx. And actually, I'll separate the integrands. We have 3 of these, so that will have like this. Minus the integral of x over x squared plus 9 dx, and also, this one can be another different integral, which will be minus the integral of 1 over x squared plus 9 dx. We set u is equal to that, and du is equal to 2x times 2x dx. We'll divide 2 on both sides, and we'll have 1/2 du is equal to x times dx. We'll replace x and dx with 1/2 du, and we'll have, well, this stays the same, of course, and minus the 1/2 is a constant, so it can go in the front, and times the integral of 1 over x squared plus 9 is now u and du. For this integral, we're going to set x is equal to arc tangent x, and that will give us the value of dx, right? Dx will be equal to 3 arc tangent x. No. X, we'll set x is equal to 3 times tangent x, and dx is equal to 3 times secant squared x dx. I know that since we're using x for the variable on both sides, it's kind of confusing, but we can't change it because we're using x for the rest of the values. So we'll replace the dx with this and the x with 3 times tangent x. We have x squared, and that will be 9 times tangent squared x and plus 9 times dx, which is 3 times secant squared x dx. I no longer have space, so I'll erase some of this part. So we have ln absolute value of x minus 1, and if we take the integral of 1 over u, that will get us ln absolute value of u, but we're going to substitute the u back in, which is x squared plus 9. So minus 1/2 times ln absolute value of x squared plus 9. But we don't really need the absolute values anymore because the inside of the absolute values will always be positive, even without the absolute values. And minus the integral of this, well, this is a trigonometric identity. 1 plus tangent squared x is equal to secant squared x. But we have 9, so multiply 9 on both sides. And you'll have 9 plus 9 times tangent squared x is equal to 9 times secant squared x. So we'll just replace what we have in the denominator with 9 times secant squared x. Okay, I'll rewrite that up here, minus the integral of 1 over 9 times secant squared x and times 3 times secant squared x dx. We can cancel the secant squares out, right? And we have 3 over 9, so we'll just have 1 over 3 left. 3 in the denominator. And I'll just rewrite all of these down. ln absolute value of x minus 1 and minus 1/2 times ln of x squared plus 9 and minus, so this whole thing, the integral of this whole thing is now equal to the integral of 1 over 3 dx. And the integral of 1 over 3 is just 1 over 3 times x plus c, right? And that's our final answer. That was pretty long. Thank you for watching, everyone. I hope you guys learned something from watching this video. Bye.